Hello. It's a SIG Node's Sidecar working group meeting. Hello, everybody. Um, it's second meeting this year. We kicked off last week with Matthias and somebody else was on a call who was silent. And we've been just catching up on all open questions we had and agreed that we need to start writing keep writing KEP draft. So what I want to do today is to see the progress of KEP draft and maybe get people working on pieces of it. Before during I do it, I also asked Francesco and Swati about topology manager, and they haven't come up with specific answers yet, but I will mention what kind of problems we may have there. So let's go through KEP draft. If you don't have a link, it's linked right here from our working group document. So yeah, we have small summary, motivational part. I think it was copied from previous KEP, so nothing worth deep mentioning. So goals and non-goals. I edited them a little bit yesterday. What we want to do is we want sidecars to be first-class citizens. So we want kubelet to support sidecar pattern. We want the job completion issue be solved. We want to mix init containers and sidecars. So init containers may utilize sidecars. And also we want to easy injection of sidecars in any pod. So these are our goals. And non-goals is any other graph dependencies between containers, or we also don't plan to support any termination ordering, at least in alpha. I doubt we will ever do that, but at least in alpha we wouldn't. And proposal part, this is where we outline what you want to do. So we introduce special flag on in containers that will indicate if it's sidecar or not sidecar. So today is called always restart policy always. So they will not block pod completion. They will be terminated when all other containers terminate, and those containers will also be restarted even when pod restart policy is never on failure. I added this line here because I think Joe and Nicole, I think we get to the point when we all believe that this is an important scenario. We just need to understand how hard it will be to implement. Joe, are you here?
Yeah. I think that's right. I just got back from break, so I'm going to catch up on this one. But yeah, I should be able to leave this part.
Okay, so I think we can leave it here for now. Okay, so Kevin has a comment. Don't be afraid to speak up. Okay. So Kevin is saying
yeah. Oh, go ahead.
Kevin is saying that restarting during termination makes sense to me in the chat.
Yeah, I think that's right. Tim Hawken had a model that I kind of liked where you basically, I'm trying to remember how to phrase it right. But you kind of make it clear what the life cycles are so that the sidecars are still kind of in an active mode and doing their normal restarting up until the right point. So I'll try and see if I can get that into the KEP in a way that makes sense.
Yeah. Oh, by the way, you mentioned that I never mentioned here in the proposal that it will complete 10-year readiness. Okay, so readiness is defined by readiness props. Okay, I mentioned here. So I also wanted to minimize kills by adjusting score, like changing score adjustment. Today we calculate score adjustment very poorly for small containers, which sidecars typically are. So I added this line here, but it may be, I'm not sure how. I don't know if it's controversial. If there will be any big concerns with that, we can remove it. But I feel like it can be important. So to give some color here, Today, sidecars are typically smaller, much smaller than regular containers. So when we calculate score adjustment, percentage of nodes that sidecars utilize is very minute. It's less than 1%. And when we calculate score adjustment, it turned out to be like 999. So it's maximum score adjustment possible. So it will be like terminated right away whenever situation happens. And lastly, I think this is controversial. This is something that I'm not sure about. We've been discussing restart backoff timeouts, adjusting them for sidecars. So today we will, when we restart containers, we will keep increasing timeout interval between restarts and all the way to up 5 minutes. And 5 minutes may be too long for sidecars because they want to be alive all the time. So the question is, do we want to do something with these timeouts?
Yeah. There might be a difference too on crash restarting when it's starting up versus like through its entire life cycle.
Okay. What is the difference?
Like when it first starts up, it might be restarting because it can't pull an image or something. So have it draw out a little bit longer to start up the pod might be okay. But after it fully starts, maybe then it has the quicker restart time or something.
Yeah, I think that makes sense. Yeah, that makes sense. And also, like, if it's not configured correctly during startup, it can have issues, right?
Does this need to be something that's really special about sidecars, or is this kind of hinting that we lack proper configurability for containers in general? Like, I'm a little worried about making sidecars like have too many like special cases versus just trying to make general cases sufficient that you can use them for sidecars.
The killer setting kind of felt like that too. Like maybe there's other containers that would want to adjust that.
Yeah,
I think simplest.
Yeah. Go ahead.
I think simplest to begin with is not to change anything and then see how it is and then make changes. If you propose too much, it'll be hard to reach an agreement.
Okay. Let me remove this part because this part was also, I added this section about ways to abuse this. Where is this section? So yeah, we'll get to that, but how users may start abusing it, and user may decide to use sidecars as a way to run regular containers. And if there is a special restart backoff timeout policy that they want, they may start using it for all the containers, and it's not what we want to encourage. So yeah.
Yeah, I agree with that. I also think it's if you start making too many things like just slightly different, then it's going to seem kind of magic to people why one container mode is like just behaving different than another container mode. Whereas if we try and keep the behavior uniform, it solves the problem you just mentioned before, which is people won't switch modes for one of the side effects. But then also, I think it'll just be less surprising. The API will be cleaner.
Yeah, I do think that word always then confusing because always here indicate that. I mean, to your point that we want to minimize amount of magic. Always is already a known word. It means something, and it means something specific for regular containers. It doesn't mean that they will be restarted during termination, for instance, during pod termination. Do you feel that this may be the argument?
Yeah, I'm worried about that. I think that's a really good point. The way that we were hoping to phrase that is that for sidecars, the way I'm hoping to do this, and I don't know if I can achieve this, but what I'd really love to do is make it clear that the sidecar's life cycle isn't in the terminating phase yet, even though kind of like the pod as a whole is. And so because of that, you would expect that its restart policy to be applied normally. So it will require some explanation, but hopefully at least like given the explanation, it'll be clear that it's like still in a mode where restart makes sense.
I added this to be done for naming. I don't know if anybody wants to take this and like fill this up. Anyway, so user stories, I think we already have user stories on the top with service mesh and logging containers. We may want to add user stories here. And I wasn't sure what kind of user stories will be useful here. If you have suggestions, please speak up. Otherwise, we can just remove it.
Yeah, I'll do a pass too. I know there was a couple people that were complaining when I was talking about termination that they didn't think that sidecars were justified at all by what I was proposing. But so we need to make sure we have, maybe it's already there, I haven't read the cases. We need to make sure we have a use case that makes it clear that like being in the init phases means that you can have like one sidecar start before another sidecar if there's a dependency. And I think there's a couple other cases. So I'll review them and make notes of that.
Okay, thank you. So in the risk and mitigation sections, I wanted to have this, how customers may abuse this feature. So first example, I have, if user decide to use sidecars to run regular containers. And I mean, this is just a brain dump, and I want to brainstorm on this meeting as well. So if you have an idea how to abuse, please speak up. And I just put different scenarios, how potentially they can abuse, but for some scenarios, I can't even come up with a way how it may make life difficult. So how, for instance, may user implement some noisy neighbor scenario with that, or may implement something very strange based on this new behavior. So first is having the most side effects is sidecars as a way to run regular containers. One scenario I came up with how it can be useful is users may decide to implement kind of timeout logic. So imagine you have one container that just runs a sleep and terminates after sleep completes, and all the other containers are running some job as a sidecar containers. So now if you effectively implemented some job execution with like maximum timeout. So this is a pattern that we cannot implement today easily, but with sidecars, customers may decide to start using it. And it worries me a little bit. So it's kind of an abuse of sidecars feature. What do you think?
I don't see the bad part of it. I mean, at the end, it doesn't put any workload in danger, no?
I think it's worth a listing. I don't think that one, for me at least, is like a showstopper, because I could imagine you could have like a parent process that also like was kind of like a watchdog and timed out, and that's also probably no better than what you have here. So I suspect that you could try and find a way to do it today, and you probably wouldn't like it better than the sidecar approach.
Yes,
Okay.
exactly. We were sort of init inside the container. Yeah.
Okay. And I listed this. So if we will implement some restarted backoff, timeouts difference, or some other difference that may benefit users, and they may start abusing it. So that's another reason why not to implement special features. Okay, balloon sidecars. This is another feature. It's again just brainstorming here. so what users can do that they couldn't do before is to allocate some large portion of resources, like CPU, for instance, and pin some CPUs in the very beginning of initialization stage. And then like they can not specify regular resources for regular containers, so they can minimize those resources for regular containers because they just reuse whatever this balloon container allocated in the beginning. I cannot come up with what's wrong with that approach, but it's something that people wasn't able to implement before. Okay, nobody sees a problem. Okay, I also don't see a problem. I just want to list
not a blocker. Yeah, just yeah.
Yeah, but I listed this scenario here because of I thought a lot about like how init containers and regular containers reuse resources, especially keeping in mind topology manager and CPU manager. And Francesca promised to come up, and Swati came back with some answers. So yeah.
Yeah, I mean, I think this is a good list. I'll try and add anything I can think of too. I think the interesting thing about what we're doing is like people were already doing sidecars just in another way. And so unless we actually make the situation worse, then like if you can argue that we made it strictly better, then I think we're in pretty good shape for most cases. I am a little worried about like people wanting to do complex ordering and things, but even there, I'm still think we're probably better than they were before.
Okay. Yeah. Do you want me? You said you like my list. You probably read through all of it, but let me finish. Okay, just for completeness. Sidecar that never becomes ready. It's similar with init containers that never complete. So I don't think there is a new problem. Intentional failing of or terminating sidecars. We will abuse kubelet a little bit because it will keep restarting it even for jobs. It may be unexpected, but I don't think there is a problem with that. I also try to think of different ways customers may abuse our eventing system. So let's say you have a job and you want to send some events back to kubelet. So you have a sidecar that terminates, and termination will be translated into event back to kubectl. So you can try to come up with some understanding what's going on based on termination of sidecars and restarting of sidecars. But yeah, this is such a long shot, so I didn't even list it here. And then keeping sidecar alive. Somebody added it right just now, right?
Yeah, that was me. Don't know why it's not having my name on there.
So I don't think sidecars can keep job alive. It's quite opposite. It will terminate the job, right?
It's something we have to consider. We may want, based on the use case above with logging, you might want to be able to hold termination up for a while so that you can make sure all the logs get logged out. But that same kind of thing could be abused potentially by one user keeping their pod alive way too long.
Okay,
so just something to consider.
Termination.
Yeah, on termination.
We're a little bit limited there because there's like the termination grace period and some other things that I think from an API perspective, it would be pretty hard for us to violate. But we can think about, like, I'm assuming as long as you extend that far enough that you within those bounds, you could kind of get more time. It's a little tricky because I'm expecting a lot of sidecars to get injected by like an admission controller or an admission webhook or something. And in those cases, like, I don't know if you should really be extending somebody's termination grace period when you put the sidecar on.
And it's hard to tell the user from the webhook at that point too.
Yeah, it all looks the same. That's a really good point. This does bring up another thing I was thinking, which is, are there risks that we introduce that exist only because people have already been creating sidecars today and have binaries that work as sidecar binaries, even though there is no built-in sidecar mechanism, and they might migrate these to this new approach and then get some kind of behavioral change they didn't expect. I wanted to think that one through, like say like Istio or whatever, any mesh, anybody, they've already got sidecars and they just kind of naively start migrating to this new thing. Are there any kind of like rough edges that would be like super surprising for them?
Yeah, if there is no comment on the call, it also comes back into backward compatibility issues, because it's one of those issues when you take some assumptions and then you try to apply those assumptions to something that doesn't have the same behavior. I think it will be minimal risk because sidecars typically wants to terminate themselves when other containers terminating. So I think they will be, I mean, if nothing else, they will terminate earlier than we will terminate them.
Yeah, I'm not super worried about it. Yeah.
Or maybe one option may be they will start terminating themselves, but we will restart them because it's too early for us. And it's termination stage of a pod. So we will restart them and they will think that they just starting up. So that maybe.
Oh. Yeah, I mean, that could have some, yeah, we'll have to, I might actually go through and look at like a couple concrete cases, because ones that are doing metrics might like be registering metrics versus, yeah, I don't know. I'll have to think that through.
I think as long as we document it correctly, people should be aware about what will happen if they do some edge cases like this, no?
Yeah, I think documentation is probably like all we're ultimately going to be able to do. If we do identify something that's like really weird, then like maybe we can give specific guidance for that particular case. But I actually suspect that we might not find anything here, but we should, you know, John Howard or anybody working on Istio or any of the other main ones, maybe we'll be like a early adopter can hopefully give us good feedback.
So another, again, esoteric things that I was thinking about is if customers will set liveness probe that defined on sidecar but actually pinging the job, then you kind of don't terminate the job, but you get a signal about liveness behavior of job. So today, yeah, I don't know how even to express it, but what can be the risk here? But I know this. You can get two containers, and one of the containers have a liveness prop, and this liveness prop not necessarily pinging the port opened by this container. So you can ping a port of different container, and then by doing that, you may get a signal about liveness of a job without terminating the job. But I think there are better ways to do that today. So I don't see it's a big abuse.
Yeah, that sounds right.
Yeah, just trying to spark conversation and some ideas what other situation may happen. Okay, then we have backward compatibility. We will have upgrade and downgrade scenarios covered in production readiness review. Outside of that, I was trying to come up with ways how existing code may break, like existing third-party code. So we will fix all the bugs in kubelet and in the control plane, but outside of them, so some assumptions that people may take on pods today that will break with sidecars. So one assumption is nothing is running in the pod when a init container starts. So if we init container somehow enumerates processes or relies on the fact that there is only like they only running this like themselves, so they may break because of sidecars. Not sure if it's significant risk is just one of the behaviors that may break for customers, and if they rely on that, they will be broken. I think the only way around it is to document things and say, like, if you're doing that, we will break your assumption. Second one is obvious, incorrectly calculating resource usage. So if people don't pay attention all the new fields, so they don't parse it as a strongly typed object, but they just like only look at fields that they're interested in, they can miss the new field added to init containers, this restart policy, and they will calculate the resource usage incorrectly.
Yeah, I've got a Prometheus or Grafana dashboard that would definitely have to be modified for that.
Okay. I think it's inevitable. Whatever design we will come up with, it will be, oh yeah, sorry. It will be a similar situation. And lastly, if there is a controller that strips out everything they don't know about, then they will run into problem, because if they strip out restart policy always from init containers, then they will render the pod unusable. I don't know if anybody ever doing that, but one of the risks I came up with. Okay, I also don't think nobody doing it.
I think most of the I think most of the modifying webhooks, I think the API is to patch the existing thing, not here is the whole thing back modified. So that might not be that big of a risk.
Yeah, I mean, hopefully, if the way they serialize things doesn't support new fields, then it may be a problem.
Mm-hmm. But I'm thinking the common way of actually doing that might prevent that problem.
Yeah. Okay.
Maybe some open policy agent rules could reject the pod.
Mm.
But
yeah, I can see that.
Okay. So they fail to parse it. They crash with the error, and this error serves as a pod being unschedulable. Yeah, it is a risk. Yes. Okay. Yeah. Okay. I think backward compatibility is covered with all the assumptions. I think we just need to document all these situations and behaviors. Shouldn't be a big problem. And upgrade and downgrade section, I haven't completed it yet. So if somebody wants to take ownership, that would be great. I think kubelet will reject new fields. I'm pretty sure it will, but I didn't check. So maybe we need to check if existing kubelets needs to be modified, so they will not accept pod with this new restart policy always. Okay. Resource calculation for scaling and pod admission. So I put this formulation. Today we calculate resources maximum of maximum of init containers and sum of containers. This is quite straightforward formula. More complex formula will be like if we just add sidecar containers here, formula will be like this: max init containers plus assuming that all sidecar containers running the same time. And we also add the sidecar containers to all the regular containers, and then take maximum of this one and this one. But this formula is not completely correct. Actual formula should be more complex. Like imagine you have a init container. the use of this init containers will be this container resources itself, plus all the sidecars that started before this init container. So you need to go through each of them like sequentially and like calculate this formula, and then take max of it. And then you also need to sum up all sidecars to all regular containers, and then take max of these two numbers.
So yeah, we need to make sure that we somehow expose this through the Prometheus metrics in a way that this can be reproduced so that users can track it. I've been doing this kind of calculation on pods already, and it's kind of painful. Maybe we just export the actual final result, since it's getting more and more complicated.
It's a nice idea.
Do you think this metric needs to be exposed by scheduler or kubelet?
I'm not sure where the metrics are exposed now.
I know how to do it from kubelet. I'm not sure how control plane can expose it.
Yeah. But it's common to scrape all the kubelets, so maybe that's the right place to do it. I don't know.
Okay.
Is the scheduler going to need it anyways, or is it going to be able to get by without knowing that?
No, it will need to know it if it's weighing it against the quota.
Yeah, if it
Well,
needs
it's
to
not
compute
necessarily
it.
the scheduler, but the API server somewhere for quota needs to handle it.
Right.
Yeah, I'm actually still not completely clear on how scheduler calculates it. Does it calculate final use when init initialization stage completed already, or it still allocates all the memory in case pod will be restarted and needs to run through initialization again?
It reserves. Now it reserves the max of all the containers and the sum of the regular containers, whatever's the largest of those, against the quota at least.
Okay.
So
it assumes that it may restart again, and it will need all.
yes.
Okay. That's fair. Okay, so we don't need to have more complex logics than that.
Yeah.
But it's a good point about formula. Exposing this number. Okay, and topology managers and CPU managers. Here, as I said, I pinged Swati and Francesca to look at code, and yeah, maybe I need to start looking myself as well. The complication here is how to, like, we already have problems with reusing resources after init container is completed, because especially when containers demand full CPU or they want to pin CPU somehow, then it may be, in some situations we have a problem that containers cannot be scheduled after initialization stage completed because there is no more resources. Anyway, that's something that need to be cleared out, and especially with this complex formula, when init containers will have different set of sidecars scheduled already, we need to understand how like allocation and alignment of all the CPUs will work with topology manager. I hope it.
You might be able to simplify it and just assume that when it's successful, all of the sidecars will be running at the same time. Right? Take the max that it will ever hit and reserve it, rather than, well, it only got to that index. Right.
Yeah, I'm mostly worried of situations when you have a scope of pod for NUMA node allocation. So you want to run whole pod in one NUMA node. And then
so there might be two different function or calculations, then there might be the one on the node versus what's used for quota.
Yeah, this is like topology and CPU managers. They put advanced kind of hints on how to schedule specific containers on specific CPUs, and that's where I hope there is no complexity. I just don't really know how it works.
Mm-hmm. Yeah, I don't know either.
Okay. So yeah, I think this is all we have today. We still have whole PR section to complete and test plan.
I added another problem up at the top. I don't know if it really fits, but something to maybe talk about.
Secrets, okay. This one?
Yeah.
It's a good use case.
Good use case.
Yeah, that's nice. Yeah, it should be possible with one. I would be a little bummed out if somebody had to have like one init container to do the first pull and then another one to do the watch.
Yeah.
Yeah, I think HashiCorp people will be happy with this.
But you got the probes, right? So you should be able to like indicate like, oh, hey, I've got my first pull ready. Now you may resume initialization.
Good. Oh, yeah, I didn't mention termination anywhere. So I think in implementation details, you can get
I'll do a pass in the next couple days and focus first on termination, then I'll do a more general pass. And it's just some of that inside. Yeah, you can add a section there. This week is definitely cup week for me.
Okay, so we have test plan and upgrade downgrade strategy. All this.
Do we want? I don't want to belabor it, but do we want to list out some of the alternatives that have been considered and rejected somewhere in this? I feel like that might help us stay out of double jeopardy with people that are like, why aren't you doing X? We're like, oh, we thought this, like, there's been like N iterations of sidecars, and there's a ton of things that we've seen and tossed out. In fact, we've got, I think, a big list on our meeting notes of some of the rejected ones. I can help fill that out too. But
I can do it because I already have a document for that.
Oh, awesome. That's even better.
Thank myself. Matthias, do you want to take any section here? Maybe PRR or?
I can check the upgrade downgrade if you want.
Okay, yes. Thank you.
Maybe version skew with that. Those usually go together.
Okay.
Yeah. Oh, what's the difference? Version skew is when you have like a new kubelet and an old control plane, or the opposite? Or
Yeah.
Okay.
That's the main one we're worried about.
No, I don't know your email, so I cannot assign it as a comment. But you probably remember. Okay, and test plan. I think that might be a good, a good thing to list. To list some test cases to demonstrate that we know what we're doing. Many times it was, I mean, all other attempts to do sidecars were always rejected because of lack of testing that we assumed. And maybe it will be a good idea to list all the tests that we want to implement. I can start filling it up and then we can go by example.
Sounds good. Yeah, I'm willing to do a review pass and add anything after someone's done the first one.
And Joe.
It's me.
Yeah.
JP Betts.
Cool.
Yeah. Thank you.
Perfect. I think that will be quite enough. Is there anything missing?
Maybe not inside the document, but we should register ourselves for the KEP list in SIG Node.
Yeah, we'll do that. I'm mostly thinking about API review, like thinking of a time when we can start presenting this document to people like Jordan or somebody else. So I think maybe if we will complete these few sections by end of week, we can, like next week, we can start doing it. Thank
Yeah, I think that's a really good idea. I've noticed they like to see it early. I mean, we already have basically a proposal for what the main API changes. So I think that's a good plan. Like, regardless of what we achieved, like we should go on to their next schedule and just tell them like, hey, this is how we're thinking of doing it. That kind of gets them ready.
Okay.
I've done that in the past. They seem to like it, especially early in the cycle when they're less busy, to get a chance to kind of like get their heads around something, and that makes it easier for them later.
Okay. Let's try, like by next meeting for sure we need to have a document ready to share.
I agree.
Well, if you have time earlier, it's even better because we can have pre-reads. Thank you. Anything else people want to discuss today? If not, then we can get 13 minutes back. Thank you, everybody. Bye-bye.
Thanks. Take care.
Thanks. Bye.